So in this video, we'll consider some basic things about even and odd functions, define even and odd functions, discover what happens when you multiply even and odd functions together, how to find the even part of a function, and how to find the odd part of a function. So an odd function is like when you insert negative x into the function, then you get -1 times the function back. So examples of this are x cubed, sine x, hyperbolic sine of x. An even function is when you put -x into the function, you get the function back without any minus sign. So x squared is an example. An even power, x to the fourth times cosh x is a even function. The absolute value of x is the even function, while x is an odd function. So we can prove that an odd function times an odd function is going to be an even function. So for this function, we have two odd functions, then we get the -1 squared out in front, which gives you plus an odd function times an odd function. So that means an odd function times an odd function is an even function. Here we have two even functions. We put even function of -x and even function of -x, and we get even function squared is equal to what we started with. So f of x is even. But if you have an odd function times an even function, that will be an odd function because the -1 comes out in front here. This minus sign goes away, but then you have a minus sign times the original function, so that's an odd function. So if you write a function in this way that exists for positive x and negative x, then we have f of x over 2 here, f of x over 2 here, so that adds up to f of x. But this term and this term have opposite sign, so they cancel out in the sum. But if you try this with some kind of function like e to the x, then the even part of the function is hyperbolic cosine, and the odd part of the function is hyperbolic sine. So something to look out for, the symmetry of the function, whether it's even or odd. And I have a challenge problem for you. Show that the derivative of an odd function is an even function, and vice versa, the derivative of an even function is an odd function. And if you have an odd function defined on the real line and it's continuous, show that it has to go through the origin. So that's the challenge. Hope you learned something basic about even and odd functions.